Hey, I don't have headphones in, so I hope this works. This is with regard to Adam's questions that he emailed me this morning. They're for study sheet for test 5. And we're going to go over problems on the study sheet 3, 4, and 6. So problem 3 is a challenging problem. There's 2 problems on the study sheet for problem 3. Just do the second one. The first one's rather difficult. So we're just going to do the second one right here. This is more like the one on the test. There's no logarithms on the one on the test. So you're given 2 functions. You're given that f of x equals x plus 3, and the function g of x is equal to x squared plus 1. Some functions are simply substitution problems. And for some reason, because of the way that they're written, they scare people. So let's try the first one. This one is f plus g of 3. The first thing you want to do is you want to rewrite this. You want to say f of 3 plus g of 3. And what this means is you're just going to go to the f function. This one says go to the f function, replace the x's with the 3. So I'm going to go up here to my f function. I'm going to replace this x right here with the 3. So let me just do this in another color. I have a little bit of delay on my writing. So we're going to take that and we're going to put it right up here and we're going to put it in. So we're going to say 3 plus 3. That's all you have to do for the first one. Then it says go to the g function. Let's do a different color for that one. All right, now we're going to go to the g function and we're going to replace this x with this 3. So we're going to go up here and we're going to replace that x with the 3. So now we're going to say, we're going to add to it the g function, which is this whole thing, except instead of the x, we're going to replace the x with the 3. So we're going to have 3 squared plus 1. So we have the orange function was the f function, the blue function was the g function. We simply replace the x's with 3's. And now we just do the simple math. So we get 9 plus 1 is 10 plus 9 is, oops, so we have 6. I keep doing that. 6 plus 1 would be 7 plus 9. We get equals 16. So that's all there is to that one. The next one's really similar. You're just going to separate it out. So we're going to find f of 3 minus g of 3. You're going to get the same answers. F of 3 was 6, and g of 3 ended up being 10. But let's just do it all over again. We're going to go to the f function. Here's the f function. We're going to replace it. We're going to do the exact same thing. We're going to take the 3 and we're going to put it where the x is. And we're going to get 3 plus 3. Now here's the tricky part, and this is tricky. We're going to subtract the g function. So we're going to subtract the whole thing. So we need parentheses. So we're going to take the 3 and we're going to put it up here into the x, because we're going to, this is the g function. Here's the g function. We're replacing the x with a 3. We're going to square it, so that's going to be 9 plus 1. So the answer to this one is going to be 6 minus 10, and we're going to get minus 4. All right, so that's that one. Now the third problem is a little bit harder. This is called a composition of functions. This is like a little, you can't really see it there, but it's a little open circle like that. So instead of separating it into 2 like we did here, this one we're going to like kind of huddle them together. So the f is going to stay on the outside, and we're going to add parentheses f of g of 3. That's how you say that. So you start from the inside out, you go to the g function. That's the blue function. You go to the g function, you put the 3 in, again, where the x is. So we're going to have 3 squared plus 1 is going to give us 10. So we're going to get f of, since when we put the 3 in, it's going to give us 10 into the g function, because we have 3 squared is 9 plus 1 is 10. We're going to get 10. So g of 3 equals 10. This equals 10. Getting really messy here. So instead of writing g of 3, we're just going to put 10 in there. Now here's the second part. Now we're going to go and find f of 10. So we're going to go to the f function, and we're going to put 10 in where the x is. So we're going to get 10 plus 3, and we're going to get 13. So functions are just substitution problems. On the first two, you just put 3 into the f, 3 into the g, and added them. The second one, you put 3 into the f, 3 into the g, and then you subtracted them. And on the third one, you kind of huddle them together. You find g, you put 3 in the g function, and then you put that answer into the f function. A little tricky. You might need to practice a couple more of those. All right, let's try the next problem. I don't want this video lasting all day. All right. These, you have to know your sine, cosine, and tangent. So you need to know your SOHCAHTOA. So what you need to know is sine is opposite over hypotenuse, cosine is opposite adjacent over hypotenuse, and tangent is opposite over adjacent. So every one of these, what I do is I draw a little coordinate system, and I'm going to put 60 degrees in this one, and I'm going to, the one opposite the 60, this would be 30 up here. I don't have space to write it, but the one opposite the 30 is 1. The one opposite the 60 is always a square root of 3, and the one opposite the right angle is always going to be 2. We're going to go through, let's do it for each one of these. Okay, this one, instead of being a 60-degree angle, it's a 30-degree angle. So this is going to be 30. The one opposite 30 is 1. See how these change? The one opposite the 60 is going to be the square root of 3, and the hypotenuse is going to be 2. See how the square root of 3 is here on this one, and the square root of 3 is down here in this one, because the one opposite the 30 is 1. Opposite the 30 is 1. Opposite the square root of 6, opposite the 60 degrees is square root of 3. Opposite the 60 is going to be square root of 3. All right, let's do the last one, 45 degrees. So that's going to be more in the middle. So we get 45. Now this one's a little different. The one opposite 45 is going to be 1. The other one's also going to be 45, so it's going to be 1. The one opposite the 90 is going to be square root of 2. These have to be memorized. So the first thing you want to do is go through and write your triangles. Now we're going to start back in the beginning. We're going to take 2 times the sine of 60. Well, the sine of 60, it's going to be the opposite, so it's going to be the opposite over the hypotenuse. So it's going to be the square root of 3 over 2. All right, let's move on to the next one. Now we're going to have 2 times the sine of 30. So the sine is still the same thing, sine, so it's going to be opposite over hypotenuse. So it's going to be 1 over 2. And we have one more of these to do. Plus 2 times the sine of 45. So sine is going to be opposite over hypotenuse. So it's going to be 1 over the square root of 2. Now this one you need to rationalize, so let's just get that over with. So it's going to end up being 2 times square root of 2 over 2. Now, if it would have been cosine, we would have done adjacent over hypotenuse. If it would have been tangent, whoops, let me find something unique. If it would have been tangent, it would have been opposite over adjacent. So you have to pay attention. Sine is always the one that's opposite over the hypotenuse. As you can see, opposite over hypotenuse. Okay, now we just need to work these out. So the 2's cross out. You get the square root of 3. The 2's cross out, you get 1. And the 2's cross out, and you get the square root of 2. And that's your answer. You can't combine them. None of them are like terms. Okay, last one. This one's a little crazy. You have to solve this one for z. So we're going to solve it for z. So we need to free the z. It's like a little puzzle. Free the z. So here we go. First thing you want to do when you have parentheses, you want to distribute and get the z out of the parentheses. So I'm going to distribute. This one's a little funky. 3kt over mz minus 12k squared over m squared. Now we're trying to get this z by itself, so I'm going to take this term and put it over there. So I'll just put the 5s plus 12k squared over m squared. Whoops. Yeah, did I do the right thing? Yeah. All right, equals 3kt over mz. Now, this is a little tricky. Your z is on the bottom and you're thinking, how can I get it on the top? Well, if you multiply both sides by z, you're going to get it in the numerator. This is probably the trickiest part of the whole thing. So the z is no longer here, but it's up here. Now the question is, do we distribute it through? Well, if we distribute it through, we're going to make more than one z. So we don't want to distribute it through. What we're going to do, try to get this, is we're going to find a common denominator here, which would be m squared. And so we're going to get 5s m squared plus 12k squared times z. And on this side, we're going to get 3kt over m. What we're going to do is we're going to multiply both sides by the reciprocal of this guy. So we're going to multiply both sides. We're going to flip this whole fraction here and multiply it on the other side. So multiplying both sides by the reciprocal. If we multiply this side by the reciprocal, it's 1, so it's not there anymore. So here we go. So we're going to get z equals what we had there, 3kt over m, times the reciprocal of the pink. So it'd be m squared all over 5sm squared plus 12k squared. And we can do a little bit of reducing, not too much. So we're going to get z equals one of these m's going to cross that m's going to cross out with one of these. Looks like that's about all we can do. So we get 3ktm over 5sm squared plus 12k squared. Nothing really to feel good about there. You don't know if you got it right or wrong, but your z is free. And the key here is multiplying both sides right here and here by the reciprocal of the pink. So hopefully that helped. Let me know if you have any other questions and I'll do another video for you. That's it for these 3 problems.